Hello everyone, I'm Mohit Jain from MJ's Maths and Stats, that's MJ Magic Studio to you. A 7-digit number comprises of only 2s and 3s. How many of these are multiple of 12? That means this 7-digit number is divisible by 12. Divisible by 12 means it is divisible by 3 and it is divisible by 4. The divisibility rule of 3 says sum of digits should be divisible by 3, and divisibility rule of 4 says last 2 digits of the number should be divisible by 4 or should be 0, 0. But here we don't have zeros. We have only 2s and 3s. Since the domain of divisibility for 4 is small, that is only last 2 digit, we will first confirm ourselves with what should come at last 2 digit. We have only 2s and 3s. So only multiple of 4 which we can have with 2 and 3s is 32 and nothing else. That means last 2 digits of these 7-digit number should be occupied by 3 to 32. Done. Now I'm dividing this into 2 parts. First 5 digits and then next 2 digits. The sum of these 7 digits should be a multiple of 3. Now last 2 digit sum is fixed at 5. That means the sum of these 5 digits plus 5 should be a number which is divisible by 3. And we have only 2s and 3s to form these 5-digit number. So let's see what can be here in place of these 5 vacant places so that the total sum is divisible by 3. We start with 2. If I take all 2's, then 2 plus 2 plus 2 plus 2 plus 2 is 10. 10 plus 5 is 15, which is divisible by 3. That means first frame of numbers possible are 2, 2, 2, 2, 2 and then 3, 2. This is a 7-digit number divisible by 3 and also divisible by 4. So we have one number with us. Now in place of 2 I can write 3. Now I see that total becomes how much? 16. In place of this 2, if I write 3, total becomes 17. In place of the third 2, if I take 3, the total becomes 18 and 18 is divisible by 3. Now the first 5 digits 3, 3, 3, 2, 2 can be arranged in factorial 5 by factorial 3 factorial 2 ways. 5 object can be arranged in factorial n ways, but since 3 3's and 2 2's are alike item, we divided by factorial 3 factorial 2. So this would be 5 into 4 by 2, that is in 10 ways 3 3 3 2 2 can arrange themselves in these 5 places. That means another 10 numbers are possible with top 5 digits 3 3 3 2 2 permuted and the last 2 digit 3 2. Now if I move on by replacing this 2 by 3 and again this 2 by 3, my total ends up to 20, which is not divisible by 3. So I stop at 1 plus 10, that is 11. How many odd numbers with distinct digits? Distinct digit means repetition is not allowed. Can be created using the digits 1, 2, 3, 4, 5, 6. How many odd numbers? Odd number means it should end with 1, 3 or 5. Now they haven't asked us that our number should be of how many digits. That means we are free to produce numbers of any digits. So we'll start with one digit number. How many one digit number we can have which are odd? We can have 1, 3 and 5. That means 3 numbers can be formed which are of 1 digits and are odd. 2 digit numbers. A 2 digit number is an odd number when it ends with 1, 3 or 5. That means for the last place, unit place, we have got 3 options. 3p1 ways we can arrange these 3 digits on one place. Now when one digit is already occupied in the last place, we are left with 5 other digits which need to be arranged in this one place in 5p1 ways. 5 into 3 is 15. 3 digit numbers. On the similar ground, we can find the answer. Last digit or unit digit can be taken up by only 3 digits, 1, 3 or 5 in 3p1 ways. The remaining 2 spaces would be occupied by the remaining 5 digits in 5p2 ways. 5p2 is 20 into 3. We can have 60 numbers of 3 digits which are odd. Similarly, 4 digit number would be 3p1 for the last digit and 5p3 for the remaining 3 places. 5p3 is 60 into 3, 180. 5 digit numbers 1, 2, 3, 4. Last digit need to be occupied by 1, 3, 5 only in 3p1 ways. Remaining 5 would be arranged in these 4 places in 5p4 ways. 120 into 3, 360. Then we can have a 6 digit number also. 3p1 for the last place and 5p5 for the first 5 places. 120 into 3, again 360. So the total number of odd numbers with distinct digits that can be created are 360 plus 360, 720 plus 80 and 100, 900, 960, 975, 978. What is the sum of all possible numbers of 4 digits which can be formed using digit 3, 5, 5, 6 once only? We need to find the sum of all possible numbers. First basic step, number 1, find sum of all digits given. 3 plus 5 plus 5 plus 6, 19. Step number 2, find how many numbers can be formed if 3 is in the beginning. That would be factorial 4 minus 1 divided by, since these two 5s are occurring twice and are alike items, divided by 2, factorial 3 by factorial 2, that is 3. Step 3, simply multiply the two results we have in step 1 and 2. 19 into 3 is 57. This is a 4-digit number. The sum of all the digits appearing in any column is 57. Sum of all 4-digit numbers can be quickly calculated as, write 57 4 times after one place shift towards left. 57, 57, 57. And now just add up all the columns. 7, 7 plus 5, 12, 1, 12 plus 1, 13, 1, 12 plus 1, 13, 1 and 6. In how many ways can the letters of English alphabets, there are 26 letters, be arranged so that there are 7 letters between A and B? Now there is a small story. There are 7 letters between A and B. Which 7 letters? Since 2 are A and B, we are left with 24 letters. Let us first select 7 letters which will appear between A and B. Since it is selection, we can do it in 24C7 ways. Now as we see, there are 9 people in this particular group. These 9 people, A, B and 7 people between A and B, will always remain together. That means now we need to use our concept of grouping. Formula for grouping is n minus g plus 1 into factorial g, where g is the group size. Here our n is 26. 26 alphabets need to be arranged, where group size is 9. 9 people or 9 alphabets will be always grouped together. So in how many ways I can arrange them? I would be arranging them in 26 minus 9 plus 1 into. Now we need to see how these people in the group are behaving. We have a group of 9 people. A and B are at the corner and 7 people are in the middle. Now we can see that these 2 people would be arranging themselves on the corners in 2p2 ways, and these 7 people can also arrange themselves among these 7 places in 7p7 ways. So instead of writing factorial g, we would be dividing this part in 2 parts. So the group arrangement would be factorial 26 minus 9 plus 1 into 2p2, that is factorial 2, into 7p7, that is factorial 7. So ultimately, in how many ways we can do this arrangement? It is 24c7 into 26 plus 1, 27, minus 9 is 18, factorial 18 into factorial 2 into factorial 7. Let's solve this further. Factorial 24 by factorial 7. 24 minus 7 is 17 into 18 into factorial 17 into 2 into factorial 7. 7 goes out, 17 goes out. 18 into 2 is 36. 36 into 24 factorial ways. In how many ways the letters of the word Patliputra we arranged? Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 letters. A few are alike. A 3 times, P 2 times. Then we have T occurring 2 times. Then we have L, I, L, R. 5, 6, 7, 8, 9, 10. And then U. 3, 5, 6, 7, 8, 9, 10, 11. Yes, 11 of these. In how many ways the letters be arranged without changing the relative order of vowels and consonants? What do we mean by this concept? Relative order of vowels and consonants remain unchanged means the character of the word as far as vowels and consonants is concerned shall remain unchanged. That is, what do you mean by character of the word? P is consonant. The character of this 11 letter word is CV, 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 CCV. That means whatsoever word we form, the character should be CV, 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 CCV. We have got 5 vowels, 3 times A, 1 I and 1 U, and 6 consonants. It simply means that these 6 consonants will occupy only these 6 places in 6p6 ways, and these 5 vowels will occupy these 5 places only in 5p5 ways. But since few items are alike, we need to divide our answer by factorial 3 for 3 A's which are alike, by factorial 2 for 2 P's, by factorial 2 for 2 t's. This is known as discounting in counting. When we do this discounting, when we have alike items. So this sum was relative order remains same, and also in case of alike items we do discounting. Discounting means dividing by factorial r. So let's see the final answer. Factorial 6 into factorial 5 by 6 into 2 into 2 is 4. So this should be 120 and 30. 30 into 120, 3600. A man has 9 friends, 4 boys and 5 girls. In how many ways can he invite them if there has to be exactly 3 girls in the invitees? First thing is for sure, out of 5 girls, only 3 need to be invited. So he may select these 3 girls in 5C3 ways. Now, he may invite these boys, or he may opt out not to invite these boys also. So in how many ways he may invite 4 boys? That he may or may not invite them is 2 to the power 4. One boy may be invited in 2 ways. Either he would be invited or he won't be invited. So one case, 2 ways, 4 boys can be invited in 2 into 2 into 2 into 2, that is 2 to the power 4 ways. That is 5C3 is 10, 2 to the power 4 is 16. In 160 ways he can invite his friends. The number of ways the letters of the word triangle to be arranged so that the word angle will be always present. Word angle will always be present. What does it mean? It means that 5 things always occur together in given order. 5 things always occur together, which accounts for grouping effect, and in given order, which accounts for these 5 items would be treated as alike items. So grouping effect is n minus g plus 1 into factorial g, and alike items is divided by factorial number of alike items, isn't it? Now we shall start. 1, 2, 3, 4, 5, 6, 7, 8. N equals to 8, G equals to 5. So final answer is factorial 8 minus 5 plus 1 into factorial 5. Grouping effect done. Now since these 5 items would be treated as alike items, divide this by factorial 5. Given order effect done. 5 5 cancel. 8 minus 5 is 3 plus 1 is 4. Factorial 4 is 24 ways. Answer. 3 ladies and 3 gents can be seated at a round table so that any 2 and only 2 of the ladies sit together. In how many ways this can be done? Let us first arrange 3 gents on this circular table. 3 gents can be arranged in factorial 3 minus 1, that is factorial 2, 2 ways on this circular table. 2. Now 2 ladies should sit together. Which 2 ladies? We don't know. So let us select 2 ladies from these 3 ladies first. That can be selected in 3C2 ways, that is 3 ways. Done. Now these 2 ladies can take place in these 3 vacant places. In how many ways? 3p1 ways. 3p1 is 3. Now these 2 ladies which are placed between Now these two ladies which are placed among these three spaces can arrange themselves in how many ways? Factorial 2 ways. That is 2 again. Now we can see that there are 2 vacant places and we need to arrange one lady on these 2 vacant places in 2p1 ways. That is 2 ways. Since it is and in all the phases of the stories, arrange 3 gents and select 2 ladies and place 2 ladies group and permute those 2 ladies and place the last lady in the remaining 2 places. So final effect is 2 into 3 6 into 3 18 into 2 36 into 2 72. This thing can be done in 72 ways. There are 5 speakers A, B, C, D, E. The number of ways in which A will speak always before B. There is no word called just always before B. That means what? A will speak before B. B can speak after any position of A, but A will speak before B. Let's develop few cases in it. A is the first speaker. Then B can speak at second position, third position, fourth position or fifth position. That means in how many ways these 5 speakers can be arranged in this case? Case 1, that is 1p1 into 4 of them can be arranged in any position here, 4p4, 24 ways. Next, second case, A might be the second speaker, then B should be here only. B should be speaking at third position, fourth position or fifth position. Now in how many ways this arrangement can be done? Out of the remaining 3, any one can speak at the first position, 3p1. A would be speaking at 1p1, remaining 3 in 3p3 ways. 3 into factorial 3, that is 6 into 3, 18 ways this can be done. Third case, A is speaker number 3. Okay, then from the remaining 3, any 2 would be occupying this first 2 position in 3p2 ways. A's position is 1p1, then remaining 2 in 2p2 ways. B will always come in these 2 positions only. A would be speaking at the fourth position. So the remaining 3 would be arranged in these 3 places in 3p3 ways, A in 1p1, and now B would be performing in the fifth position in 1p1 ways. 3p3 is factorial 3, that is 6. So the total number of ways are 24 plus 6 30 plus 30 60. In 60 ways this can be done. Suppose I have given you 10 speakers instead of 5. It would be a very long sum to solve, isn't it? Now just see that whenever I am seeing these 5 speakers in whatever arrangement, since there are 5 speakers, they can arrange themselves in factorial 5, that is 120 ways. Whenever I look at this particular arrangement, I can always see that A is before B, A is before B. That means in all these arrangements, I can see the same picture as far as A and B are concerned. And what is that same picture? Same picture is A is always before B. But I am not seeing the picture that B is before A. That means order of A and B need to be fixed. In these cases, this is the special case of order remain same. Simple answer is factorial 5 by factorial 2, because order remains same means treat them as alike items. And when we treat them as alike items, we discount our answer. Discounting means dividing by factorial of number of alike items. Straight away answer is 120 by factorial 2, that is 2, that is 60 ways. 8 guests have to be seated, 4 on each side of a long rectangular table. Two particular guests desire to sit on one side of the table. Let's ask them to go and sit, and 3 on the other side. That means 5 have already fixed their choices. 5 have already made their choices. We have 8 guests. We are left with 3. Of the remaining 3 guests, 1 shall be seated along with 3 fixed one and other 2 on the side with 2 fixed guests. Isn't it? In how many ways this can be done? From the remaining 3, I can choose 1 who would be sent to this particular portion, and from the remaining 2, I can choose 2 who can be sent to this particular position. 3C1 is 3 and 2C2 is 1. In 3 ways I can do that. Now I have 4 people on one side and 4 people on another side. So the total number of sitting arrangement would be 3 for the choices which I need to make into factorial 4 for arrangement on one side and factorial 4 for arrangement on other side. 4 people on 4 chairs can be placed in 4p4 ways, that is factorial 4. That accounts to 3 into 24 into 24. 3 into 576 is 1728. A family comprised of an old man, 6 adults and 4 children, total 11 members in this family, is to be seated in a row 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, with the condition that the children would occupy both the ends. That means children would be seated in these 4 positions in 4p4 ways, then and never occupy either side of the old man. That means here old man cannot be placed, here old man cannot be placed. So old man can be placed only in these 5 positions. 1, 2, 3, 4, 5. 5 positions for the old man. So he can be placed in 5p1 ways. And now the remaining 6 adults can be placed in these 2 and remaining 4 from these 5. That is in 6 places in 6p6 ways. So the total number of arrangement is 4p4, that is factorial 4, 24. 5p1 is 5. 6p6 is factorial 6, that is 720. 720 into 24 into 5 will give me 86,400. 86,400 ways arrangements are possible. There are 15 points on a plane, no 3 of which are in the same straight line, good, except 4 which are collinear. So if there are m points on a plane, out of which no 3 of them are collinear, except which n of the points which are collinear, then number of straight lines that we can form is mc2 minus nc2 plus 1. And here they have also asked about the triangles. So number of triangles that can be formed is mc3 minus nc3. In our case, m equals to 15 and n is 4 which are collinear. So number of straight lines which we can form is 15c2 minus 4c2 plus 1. 15c2, 15 into 7, 105, minus 3 into 2, 6, plus 1 is 100. We can form 100 straight lines. And as far as triangles are concerned, it is 15c3 minus 4c3. 15c3 is 15 into 14 into 13 by 6, 27235. So 65 into 7, 455, minus 4c3 is 451. We can have 451 triangles. Now find the ratio of total number of straight lines to total number of triangles. So the required ratio is 100 is to 451. Answer. A train going from Kolkata to Delhi and makes 5 stops on the way. Stop 1, stop 2, 3, 4, 5. One person enters the train during the journey. That means this person A would have entered at station number 1 or 2 or 3 or 4 or 5. Obviously, he won't be entering at the terminal station, and he haven't entered in the beginning of the station because it's given he entered during the journey. How many different sets of tickets he must have had? Now, if we assume that he enters at station 1, he would have got ticket for station 2, 3, 4, 5 or the terminal station Delhi. That means he may have any one tickets of these 5 stations. If he enters a station number 2, he may have ticket for 3, 4, 5 or the terminal 1. 4 tickets. If he had entered at station number 3, 1, 2, 3 tickets. If he had entered at station number 4, he might have tickets for station 5 or the terminal station, any 2 tickets. If he have entered station number 5, he must have ticket for Delhi, the terminal 1. Then what are the different? Then how many different sets of tickets are possible with him? 5 plus 4 plus 3 plus 2 plus 1. And now why I am adding? Because it's an OR case. Either he would have entered at station 1 or station 2 or station 3 ... Now again, at station 1 if he had entered, he might have ticket for station 2 or 3 or 4 or 5 or the terminal 1. That's why everything we are adding up. 5 plus 4, 9 plus 1, 10 and 15. 15 sets of tickets he must have had. Answer. A mother with 7 children takes 3 children at a time to a cinema. She goes with every group of 3 that she can form. Let's stop here and see how many groups that can be formed. That would be 7C3, 7 into 6 into 5 by 6, that is 35. So 35 different groups can be formed. After this, again, group 1 will be repeated, but after 35 times. How many times will an individual child go to the cinema hall with her before a group is repeated? That means out of these 35 groups, how many times one particular child is always present in any group? So if I select this particular child, maybe A, he is always present in the group. That means in how many groups he is always present is 6C2 groups, because out of 6 now we need to select any 2 to be included with A to form a group of 3. Now 6C2 is 6 into 5 by 2, that is 15. Each child may go 15 times with their mother in these 35 first set of grouping. Thank you everyone for participating. We'll come back again with more questions on PC and other topics. Email ID, Telegram number is on your screen. Feel free to email us, call us or message us with your doubts and suggestion. Please subscribe to the channel. This is Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. Thank you.